Good evening, dear students. Let's study the topic bounded and unbounded sequence in Unit 3, Unit 4, Sequences 1. This is Srimati Ashwini S, Assistant Professor of Mathematics. Now, before seeing what is a bounded sequence, let us study what are bounded above sequence and bounded below sequence. The first one which we would be discussing is bounded above sequence. A sequence AN is said to be bounded above if there exists a real number capital K such that AN is less than or equal to capital K for all n belongs to natural number. That is, if the range of the sequence is bounded above. So this was the condition for bounded above sequence. Now let's go to bounded below sequence. A sequence AN is said to be bounded below if there exists a real number small k such that an is less than or equal to k for all n belongs to natural number n, that is, the range of the sequence is bounded below. So the next definition would be bounded sequence. For a sequence to be bounded, it should satisfy both the conditions, which are it should also be bounded above as well as bounded below. Now let's see the definition. A sequence AN is said to be bounded if it is bounded above as well as bounded below. Thus, a sequence AN is bounded if there exists two real numbers, small k and capital K. We always know that the small k will be either less than or equal to capital K. It can never be greater than k, such that small k is less than or equal to an is less than or equal to k for all n belongs to n. You know, this condition is nothing but the combination of bounded below and bounded above. That is, if the range of the sequence is bounded. Now let's consider a few examples so that it becomes clear. The first one says the sequence AN defined by AN is equal to 1 is bounded since, I have to have a value n greater than 0, because if I put n is equal to 0, 1 by 0 becomes infinity, which is undefined. So the least value is n should be greater than 0, and an, whatever value you get, it will be less than or equal to 1. So here your lower bound is 0, your upper bound is 1. Therefore, the sequence defined by an is equal to 1 by n is bounded. Now let's see the second example. The second example says the sequence AN defined by minus 1 raised to n. Remember, we had studied this problem in the previous session. You know, you have an alternating sequence of minus 1 and plus 1. So here, your value should either be minus 1 or greater than minus 1, and it should be plus 1 or less than plus 1. So when I combine and write, we get minus 1 less than or equal to an less than or equal to 1. In this, upper bound is 1, lower bound is minus 1. Therefore, the given sequence is bounded. Let's go to the third example. Here we have considered the sequence to be minus n. Now since it is minus n, I cannot take 0. So I have to take a value n is equal to minus 1. So this is bounded above but not bounded below. The bounded above value would be minus 1. It is not bounded below because there is no real number k for which your an can be greater than or equal to k, because you have a negative number there. The next one, let's consider a sequence an is equal to n. Now this is bounded below because the minimum value which we would be taking is 1. So an is greater than or equal to 1. It is not bounded above because there exists no real number k such that an is less than or equal to k for all n belongs to n. And we also know every constant function is bounded. You have another sequence which is defined by minus 1 power n into n. This is neither bounded above nor bounded below. So this can be an example for an unbounded sequence. Now let's see what is an unbounded sequence. Before going to that, we would be learning what are unbounded above sequence and unbounded below sequence. Unbounded above sequence. A sequence AN is said to be unbounded above if it is not bounded above. So we would be writing the definition in a symbolic form. That is, if for every real number capital K there exists m belongs to natural number such that this AM would definitely be greater than capital K. The next definition under discussion would be unbounded below sequence. A sequence AN is said to be unbounded below if it is not bounded below. That is, if for every real number small k, there exists m belongs to n such that your AM is less than small k. So when I combine these two, I can say unbounded sequence is a sequence which is not bounded. Let's see a theorem. A sequence AN is bounded if and only if there exists a positive real number capital M such that modulus of AN is less than or equal to capital M for all n belongs to natural number. So this contains two parts. One is the necessary part, the other one is the sufficient part. Now what is the necessary part? Necessary part is they've given us that AN is bounded. We have to show that modulus of AN is less than or equal to M. When I consider the sufficient part, the given point would be modulus of AN is less than or equal to M. We need to prove sequence AN is bounded. So first let's prove the necessary part. So let sequence AN be bounded. Now since you know it is bounded, it should have a lower bound and an upper bound. So we consider two real numbers h and k such that using the definitions of bounded sequence, it can be written as h less than or equal to an less than or equal to k for all n belongs to natural number. Call this as equation 1. And then what we do is we take capital M to be the maximum of modulus of h and modulus of k. Then your mod h is less than or equal to capital M and mod k is less than or equal to capital M. Now you know when I am removing the modulus sign, I have to write a positive and a negative number. So when I do that, I get minus m is less than or equal to h less than or equal to m and minus m is less than or equal to k less than or equal to capital M. Let's call this as equation 2. So when I combine equation 1 and 2, I can write it as minus m less than or equal to h less than or equal to an and that is less than or equal to k less than or equal to capital M for all n belongs to n. So what we will do is we will neglect this h and k and write it as minus m less than or equal to an less than or equal to m for all n belongs to n. Now if I have to write this in the notation of a problem which is modulus, then I can write this as modulus of an is less than or equal to m for all n belongs to n. This was what it was needed to prove. Therefore, the necessary part is proved. Now let's look into the sufficient part. In the sufficient part, they've given you that m is a positive real number such that modulus of an is less than or equal to m for all n belongs to n. Now, since this is in terms of a modulus number, when I rewrite it in the form, I can write it as minus m is less than or equal to an less than or equal to m for all n belongs to n. This is nothing but it shows sequence an is bounded. So again, the references which I have used are Sequences and Infinite Series by N.P. Bali and a textbook of college mathematics by G.K. Ranganath. I hope you all have understood the concept. Thank you.